In this video, I'm going to talk about a very important topic, stoichiometry. As you see on the slide, we're going to calculate mole to mole calculations, mole to mass, mass to mole, mass to mass, add mass to mass, and this is a very powerful skill you're going to learn in this video. So stoichiometry is the quantitative study of reactants and products in chemical reaction. The main objective would be find the mass or moles or volume of any substance in a chemical reaction when you know one of the substances, either mass or mole, or even volume. In details objectives, you're going to predict the moles of reactant or products in a chemical reaction when the mole of one of them is known. Also, you can find out the mass of any of the reactants or the products if you know one information about any of these reactants or products. What do you expect? Amount of reactants or products? How much products or reactants can be formed or can be reacted actually? If you're giving 20 grams of Na, a sufficient amount of B, how many grams of C could be produced? So this is skill going to learn in this video. The most important part of this video, we're going to use the mole ratio after balancing the chemical reactions. So the mole ratio converts moles of one compound to balance chemical equation into mole to another compound. Let us see here. So the goal of the stoichiometry is to perform conversion, changing between units by cancelling out units until the end you end up with the units you want. Let us see this example. Now, assume that we react magnesium and with oxygen gas. It gives us magnesium oxide. Now, we have to balance it. You have two oxygen here, and then you have two magnesium. Then the ratio here, it will be 2 to 1 to 2. Of course, before we start any reaction, the product will be 0. We don't have any product. How it works now? If you have, we assume that this is assumption. If you have 2 moles of magnesium, so we need, look at the ratio here, 2 to 1. We need half, so we need 1 mole of oxygen, and because the ratio is 2 to 2, so we are expecting that the same. So as we see here, the ratio is the same ratio. We see here 2. I want you to pay attention to the ratio. This is the most important part of this lecture. I want to see here, the ratio is 2. And here the ratio is 1, is 2. So if they are the same, then they will have the same amount of moles. So when you say how many products you're going to have, so you're going to have the same number of moles, and so it is plus 2 mole. Sorry. And the final will be 2 mole. Of course, now all the time this will be consumed, minus 2 mole, minus 2 mole, and it will be 0, 0. By the way, if I want to use the conversion here, number of moles going to be calculated of any of these. Say number of moles of oxygen will be, we start with the given number of moles of known, and in our case we know 2 mole of magnesium. Then we start using the coefficient. When we use the coefficient, we go to the ratio to the coefficient of balanced chemical equations. I want to get rid of the magnesium, so the coefficient of magnesium is 2, as you see here, 2. So 2 mole Mg, and I'm looking for oxygen, always to be at the top. So it is 1 mole of oxygen. We cancel out magnesium, we cancel out mole. So 2 over 2 is 1 mole. This is in the case if the ratio is not, and this is 1 mole, and you see here 1 mole. So why I say 2? Sorry, I made a mistake here, -1. Okay, let's take another example. How many moles of ammonium can be obtained from reaction of 8 moles of magnesium? So of course, we're going to have also to balance the chemical equations. As you see here, we have nitrogen 2, and we need 2 here, and then 2 times 3 is 6, so I need 3 here. So that is be 3, 1, 2. So the ratio here before we start the reaction, we're going to be 3, 1, and 2. And always before we have 0, and after we have 0, 0. So we start how many moles of hydrogen obtained from reaction of 8 moles of hydrogen. We have 8 moles of hydrogen, so hydrogen is 8 mole. Great. Now we can see here we have 3, and here the ratio is 3 to 1, so it is 3 times. So the nitrogen is 1/3 of the hydrogen. So we need to divide the number 8 by 3 to find out what is the answer. We need to divide 8 by 3 to find out the answer, which is 2.6 or 2.7. Because when you use the conversion factor, look here, number of H2 moles is given to me 8 moles of hydrogen. This was the 8 moles of hydrogen. Then I need to open the coefficient. The coefficient of hydrogen is 3. And the coefficient of nitrogen is 1. Look here, it is 1. Two of nitrogen, of nitrogen is 1. Hydrogen mole will be cancelled, so 8.3, 8 divided by 8 by 2.7, 2.66. So I'm going to have 2 sig fig. Sorry, 2.6 mole. So nitrogen will be 2.6. As a result, now I can use this one, like 2.6, if I want to calculate how many ammonia, it is not there. It's not required. If it's not required to be calculated, just I leave it like that. So it is minus 8 mole minus 2.6 mole. Let's see another example. So we have here, we have aluminum Al react with hydrochloric acid, 6HCl. It gives aluminum chloride, AlCl3, plus 3H. Okay, and it is balanced, so we can see here 2 and 6 to 3. So the ratio is 2, 6, 2, 3. Sorry, here 2, 3. So this is just the arrows, the product. Of course, the product always 0. Reactant, the result is 0. Now let us see what's given here to me here. 6 moles of HCl. 6 moles of HCl. What is what mass? Okay, this time I'm gonna calculate the mass. Let us first calculate the how many moles. So here, look here, the ratio is 6 and 3. So hydrogen is half. So the number of moles will be 3 mole. So this is 3 mole. So we have number of moles of hydrogen is 3. Now to calculate how many the mass, as you know, the mass is mole times molar mass. And the number of moles already we calculated, it is 3 mole. And the molar mass of hydrogen is 1, and we have 2 of them, H2, so it is 2 gram per mole. So the mass will be 6 gram. This is Dr. Najib Balfakih. Thank you for listening.